Okay, so now let's look at how to find the volume of a tetrahedron. So for example, if we have a tetrahedron like this, okay, and this is the tetrahedron, and if we assign some values here, so this is 3, this is 4, maybe this hypotenuse is 5. Okay, so the basic idea is to construct a cross section and then set up the integral. Okay, so the idea is to build a cross section and then formulate the integral. Okay, so that's how do we do. So for example, how do we, if you construct a cross section and such that it is perpendicular to the x-axis. So this is a cross section, and as you can see that this is also a right triangle. Okay, so so based on the Pythagorean theorem, we can do some calculation. This is 3, this is 4, so this hypotenuse for here, this is 5 also. Okay, and also you see this is 5, this is 3. It turns out that the length for this is also 4. Okay, it's also 4. Maybe we put the 4 here. Okay, this. Now, if we want to denote the length for this part as x, okay, and why we do that? Because by constructing a cross section perpendicular to x, then I know that my integral is gonna along with x, and also I already calculated the length is 4, so the integral I'll have is gonna be something like from 0 to 4 something dx. Okay, so that's gonna be the pre-set up. Okay, but how do we find about the area of this cross section? That's going to be the main task. Okay, so as we know that if we set this part as x, and then correspondingly the length for this part, which is 4 minus x, okay, because total length is 4. Now, if we denote this is the height, okay, of this triangle for the cross section, and we want to denote height in terms of x. Okay, and similarly, if I denote the length for this part, maybe we denote it as L, and then we also want to find an expression for L in terms of x, such that I can construct the area of this cross section in terms of x, and then I can put into this integral here. Okay, so that can be the volume. Okay, the volume. So how do I find h in terms of x and L in terms of x? Well, this is what we can do. If we only look at the xz plane, okay, and this is the xz plane, and we actually can draw that. So this is 3, this is 5, and then this is 4, and then this is h, right? This is x, this is 4 minus x. And as you can see that this small triangle is similar to the larger triangle. Okay. And then the ratio of the sides actually is going to be the same. Meaning h over 4 minus x, the ratio of this over and this, are going to be 3 over 4. So we can find h is 3 over 4 times 4 minus x. Okay, so that's what we can do here. And then similarly, to find L in terms of x, we look at the xy plane. Okay, and we can draw the graph, and you can see this is L, right? So suppose this is x, this is 4 minus x, right? So the overlap for this is 4, this is also 4. So this one is easy, right? Because you can see similar things. This small triangle is similar to this larger triangle. So L over 4 minus x equals 4 over 4. Turns out L equals 4 minus x. Okay. And with this, so you can see that the area for my cross section is area is 1 over 2, right? Height times L, which is 1 over 2 times 3 over 4, 4 minus x, and then times 4 minus x. Okay. Turns out it's a 3 over 8, 4 minus x squared. So this is the area for the cross section. That's exactly what we're going to put back to this integral, which is 3 over 8, 4 minus x squared. Okay, so then the following part is just to evaluate this integral, which is v equals from 0 to 4, 3 over 8, okay, and 4 minus x squared dx. Okay, we can take this 3 over 8 out, 0 to 4, 4 minus x dx. Okay, well, square. Okay, so we can have two ways to handle this. We can use a simple substitution, or we can expand this and then to evaluate this integral. Maybe we can use a substitution. So let u equals 4 minus x, okay. Then du equals negative dx. Okay, that's something we can tell. And also, when x equals 0, u equals 4, okay. When x equals 4, u equals 0. So with all of this, we can transform our integral into 3 over 8 is still constant and nothing to do with that, and then we keep that. So remember, when x equals 0, corresponding u is 4. When x is 4, corresponding x equals 0, u is 0. So from 0 to 4, this is u equals 4 minus x, so here is u squared, and dx, which is going to be negative du, okay, so it's negative du. So put all this, so we can see, we can take this negative in front. This is negative 3 over 8 integral 4 to 0 u squared du. It turns out this is negative 3 over 8. This is u cubed over 3, right? And then so what we do is plug 0. So negative 3 over 8 is a constant. Okay, so we can so plug 0. So it's 0 minus. You put 4 there, so it's 4 cubed over 3. Okay, and then you can simplify this, right? So it's negative 3 over 8 times negative 4 cubed is 64 over 3. So it turns out 3 over 3 cancel out, negative, negative, positive, and then 64 over 8 is 8. So the volume of this tetrahedron, which is 8. Okay, so we finish this problem. The idea for solving the volume of a tetrahedron is exactly the same. You know, as long as you know these informations, and then you can always use this idea to figure it out. Okay, so thank you for watching.